Hey guys, today we are going to study the next case when the denominator of a fraction consists of repeated linear factors. So consider an example where we have 1 over x minus 2 into x minus 1 whole square. First of all, we will check if the fraction is an improper fraction or a proper fraction. So since it is a proper fraction, we start solving this fraction. Let 1 over x minus 2 into x minus 1 whole square equals to a over x minus 2, which is a non-repeated linear factor, plus b over x minus 1 plus c over x minus 1 whole square. Since x minus 1 is a repeated linear factor, so we write it in the form of b over x minus 1 plus c over x minus 1 whole square. We name this equation as equation number 1. So now I am going to tell you the logic behind writing this x minus 1 whole square as b over x minus 1 plus c over x minus 1 whole square. To explain this logic, I am considering two examples where we have the sum of two fractions. We have 1 over x plus 3 plus 2 over x plus 5 whole square, the LCM of whose comes out to be x plus 3 into x plus 5 whole square. However, we have another example in which we are solving 1 over x plus 3 plus 2 over x plus 5 plus 3 over x plus 5 whole square. This also has the same LCM while solving these three fractions. So, we are going to consider the second option while assuming our partial fraction, because if we assume the first case and our resultant fraction consists linear power as well as power 2 of the denominator, then we cannot find this term that involves linear denominator. And if our resultant partial fractions are of this form, then the term involving linear denominator will have the value of the constant as 0, and we are also safe in that case. So, continuing solving our fraction, we multiply both sides by x minus 2 into x minus 1 whole square. We get 1 equals to a into x minus 1 plus b multiplied by x minus 2. Here we have square plus b into x minus 2 into x minus 1 plus c into x minus 2. We name this equation as equation number 2. So now I am further solving this equation as 1 equals a. Here we apply the formula of x minus 1 whole square, which comes out to be x square minus 2x plus 1 plus b into x minus 2 into x minus 1. We solve this as x square minus 3x plus 2 plus c into x minus 2. Here we have 1 into ax square minus 2ax plus a plus bx square minus 3bx plus 2b plus cx minus 2c. So we get the solution as the follows. Now we combine the terms involving x square as 1 equals x square into a plus b plus x multiplied by minus 2a plus c minus 3b, and we combine the constant terms that are a plus 2b minus 2c, and we name this equation as equation number 3. To find the value of a, which is above the non-repeated linear factor, we use the zeros method, and also we can apply it to find the value of c, which is above the denominator having greater power. That is, for a, put its denominator equals to 0 in equation 2, and for c, put its denominator equal to 0 in equation 2. We get 1 equals a multiplied 2 minus 1 whole square plus b into 0 plus c into 0. 1 equals a into 1 square plus 0. So we get the value of a equals to 1. Now for c, put 1 equals a into 0 plus b into 0 plus c into 1 minus 2. So we get the value of c to be minus 1. For b, however, which is the constant term above the denominator having linear power, we compare the coefficients of x square in equation 3. So we get 1, we get 0 is equals to a plus b, or b equals to minus of a. Putting value of a, we get b equals to minus 1. So now we are putting values of a, b, and c in our equation 1. We get 1 over x minus 2 into x minus 1 whole square equals 1 over x minus 2 plus minus 1 over x minus 1 plus minus 1 over x minus 1 whole square. We can also write it as 1 over x minus 2 minus 1 over x minus 1 minus 1 over x minus 1 whole square. So here it is. We have completed the question involving repeated linear factors. I'm going to go through it again. This is the starting portion. And this is the solution. Thank you.